Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I am your host, Dean Phillips, and today I have a very distinct pleasure. We are having our one-on-one show. That means Dean Phillips will be interviewing Dean Phillips. Right off the bat, I'd like to introduce him. Welcome, Dean. It's great to be here. Thank you for having me. I'm glad to be able to take part in this show. It is my pleasure to have you. One of the things that right off the bat we like to do here on the show is ask you a question of what you see being the biggest change over the next 5 years. Well, for me, I think that the biggest change that I see is competing for workforce talent. It's something that everybody's already been seeing, but over the next 5 years is going to be a little bit more difficult. People are going to have to work on that and use things like social media, use your connections to other people, and your sphere of influence is going to be even more impactful of how you reach tomorrow's leaders. If you think about it, think about how we've done things in the past. Usually the company has always held the controls. They decided, hey, I want this person or that person, and they pretty much got to pick and choose. It is not that way anymore. And you have to entice people to want to work for you. You have to show them the value. Guest Matthew Welly was on the show here on episode 517, I believe it was. And he talked about, building a vision. And I agree with that. I think you have to build a vision for your people. You're building a culture within your company, but they have to buy into that vision. They have to believe that, this is something I want to be part of. And if they don't, then so be it. But you have to kind of lay that out for them to start. Is this something you want to be part of? Now, all of us have been on interviews, and most all of us have gone to a company and worked there and said, hey, do you think this is something? Yes, I absolutely am interested in it. Knowing full well we probably weren't interested in whatever it was, whether it was the job that we were going to be doing. Nobody got excited about working in a gas station. Nobody got excited about doing roofing and siding. 2 jobs of which I held, but both of those, it was a job, it was not a career. And I think that's what we want to do, is we want to entice people to see themselves involved in this as a career, in manufacturing. I couldn't agree more. I think that's something that we're going to have to look at and address over the next several years. When we talk about your background, how did you get involved in manufacturing? I've been in manufacturing now for 32 years, so it's hard to remember a time when I wasn't. When I got involved in it, my dad worked at General Motors. He worked at the engine plant in Tonawanda, New York. And when he worked there, it got me interested in manufacturing. But I can't say as that was the key reason. I think I was more interested on the electrical side of things, and the fact that my uncle and my grandfather were more on the electronic side got me more interested in it. And I was interested in computers and technology. So that led me into a vocational high school, something I am a big advocate for bringing back. We push those to the side where people don't need to have a skill set. Well, I often ask people a question, what is it you can do that can't be replaced by a robot or by a monkey? Okay, monkeys have gone into space, so don't think that you're above a monkey. So right off the bat, what is it you can do that they can't? What is it? And you should know an answer to those 2 questions, whether it's a robot or a monkey. What is it you can do that they can't? You better understand what your skill set brings to the table. And when I've spoken to some of the technical schools before, I always ask them, look, when you look around the room, everybody here is going to graduate with the same degree. But when you graduate with that degree, everybody in this room could be an ally or a competitor, because everybody in this room can help you get a job. They get a job at a company. They're, hey, we're hiring. And they let you know that there's an opening at the company they work for. The other thing is that they're also a competitor. All of you will graduate with the same degree. What is different about you? What is it? Maybe they give you a test to prove that you understand things or came out of there with more information than the other guy. But what is it? There's usually intangibles of when you start in a career that separate you. I used to tell people all the time, if you're in Scouts, get your Eagle Scout. That will separate you from everybody. And there's amazing how much people put value on things like that, because by being an Eagle Scout, you've shown a whole level of commitment to something that was beyond what most people ever do. And just look at the numbers illustrates that. There are very few Eagle Scouts compared to Scouts overall. Same thing, you take the number of people that have completed a marathon or have gotten a black belt. Yep, I have done both of those things, but that it separates you from the fact that it shows that you have the ability to plan for something and stick to it and commit to the outcome. Speaking of that, I would highly say that the next part of what is a challenge, I think, for companies is finding people that are committed. Are they committed to doing what they that your vision? Are they there to execute it? We talk about technology, and that seems to be a problem. It's interesting that you say that, because when we talk about things like commitment to a project or execution, why are we struggling with adopting smart manufacturing? I know that you're on the Smart Manufacturing Committee for SME, and you've spoken on the topic, but what is it that you feel is something that is not happening? What is not clicking for people? Well, that's an interesting question, because what I think people are struggling with is adoption. Are they actually ready to execute a plan? And do they even have a plan? So let's just take out of all the smart manufacturing, let's look at IoT. So what is preventing people from adopting IoT? Sensors are not that expensive compared to what they are checking and what the amount of money they can save you. I've been at several companies recently discussing this, and we're talking about why they're not using the die protection to the fullest capability. And George Karamedjev, who was one of the biggest advocates for die protection in stamping, well, George used to say that you have to have a plan, and you have to have that advocate within the company that's willing to push it. They have to make sure that it's done all the time. As soon as you don't have that person, it's going to go by the wayside. And unfortunately, that has been illustrated time and time again. We really struggle with making sure that people will execute this plan. And it can be as simple as putting a sensor on a piece of equipment, and then when it fails, nobody goes to replace it. And the other part of it is the information and the value of the information. Reports are generated off of it, but if they're not valued, I'll give you an example of Toyota. I spoke with one of the gentlemen who was involved at the very beginning of the Toyota production system and went around and did training for it. And I asked him the question of, when Toyota had the recall system because of the accelerator problems, I said, well, with the Toyota production system, what happened? What went wrong? They stopped executing their own plan. That was what he told me. He says they got to the point where they felt complacent. They felt like they had achieved kind of that level of the low-hanging fruit. They had already done it. So they didn't feel like they needed to continue doing it anymore. They didn't feel like they needed to continue. But as soon as you stop, people start to backslide. When I go into manufacturing plants, nobody wants to do more reports. Nobody wants to make sure that there's information gathered on the machines. That's for the office personnel. The people on the floor don't care about it. And that's the problem, is there's no value to them that this is gathered and it's gathered accurately. Well, you have to change that. Metrics are very, the old thing that not everything that is measured is important, and not everything that is important is measured. I'm paraphrasing there, but that's kind of one of the challenges that we have, is that the people that are executing the plan, there's nothing tied to it from their career, from their profit. They're not making any extra money because of that. Well, you need to reward good behavior and good successes. I think that a lot of times we get away from that, and we don't always communicate the value of things to the people that are working on them. They need to understand why this is important, and they need to understand why it's critical for their success as a company and as an employee. A lot of times people think, well, my job exists independent of the company. I've heard that before. A lot of people that work at GM always said, well, the union will take care of us. Well, the union only exists within the company. If there's no company, the union doesn't have a value. It's no longer part of that entity. So one can't exist without the other. So it's important for everybody to understand the shared vision and agree with it and work towards it. When you get away from that, it really has an impact on the success and the planning of it. That's on the IoT side. A lot of times people are not valuing the information that's gathered. And so you have two things working against you. The employees don't care about it specifically. If they did, then they would be ringing a bell from the highest mountain saying, hey, my sensor is out on my machine. This is going to create a problem with my parts. And then the flip side is, does the manager say, yes, I agree that we need to fix this immediately? And is the information that's gathered upriver, here, is that valued? Again, back to the Toyota production system example. Well, they think that they're okay. I've gone in plants, and I'm not going to name any names, but I've gone in there. Oh yeah, we really are. We're doing all of these things, and this is at one of the big three automotive companies, and they have all their tonnage monitors turned off. They're not even looking at that. So they have determined that it's of no value to them, that the information achieved from a tonnage monitor is of no value. And but if I go to the people in the upper office, they think that those machines are still working the same way. They think that the tonnage monitors are still doing that. And that's a problem when people think that something's happening and it's not, because there's no system in place to monitor its failure. In controls, in press controls, we call it control reliability. Well, even if you have redundancy is not control reliability. No single component can fail and allow the machine to keep running in an unsafe condition. Well, same thing here. If you think you have a system in place but there's no checks and balances, that system can fail. Nobody knows. Nobody gets upset that it's not doing that anymore, and consequently we don't value it enough. So that, to me, is one of the biggest reasons why we don't take that next leap forward in IoT, why we're not embracing AI in the way that I believe that we can, because preventive measures on plant maintenance and things like that are not comparable to predictive. Because when you look at preventive, you either are doing your maintenance too soon or too late. You're either reacting to a downtime problem, or you are doing it on a regular basis when it isn't needed. Every time the tool comes out, you're remachining it. Well, that's not beneficial either. I ran 500 strokes and I'm going to go sharpen the tool. Well, that makes no sense to do that. But if you have a tonnage monitor, or you have some kind of a control or some type of a system, or even AI in there that's predicting when this tool is going to be needed to perform that function of sharpening, then you have usable information. It is valuable. And I think the value is the problem that we struggle with. If you think about that, I think you'll realize that there's more challenges that we still have to do. When we think about challenges, what is it you see when you're out there in manufacturing that comes up with a reason why a company is successful and why they're maybe not so successful, regardless of whether or not they're using technology? That's one of those things that when we look at technology, it doesn't automatically translate to success. It can be a predictor, but I can go into different companies that have different genres of products. Okay? If you're making parts for, let's say you've been doing things for years for the military, you already have invested in the tooling. Sometimes the parts are so low volume and so high precision that it is not worth another person competing with you on that part. So consequently, what winds up happening is that they stick to old things. They don't need to have, in their eyes, they don't need to keep track of the process. They're not trying to improve or get better. There's no real reason for them to do that. They have a contract. They're going to continue to fulfill it. They don't need to be taking that next step. It's interesting that more companies that are job shops who really are tied so strongly to their ability to reduce downtime don't embrace technology more. They think of it as a cost. They don't think of it as an investment. And that really is a sad situation, because more than anybody, they can see the value of reducing downtime and things like that. They don't typically, because their runs are so small to program things and to do jobs, they're not like a Toyota or a Nissan or General Motors or anybody else who is repeating the same jobs over and over and over and over again, and it's very predictive, so that they can actually invest in things like quick die change, because they know that they're only going to be loading in 5 or 10, or even if you're doing 100 tools, if you're doing them all the time, it's worth investing in those things. I think a lot of times the job shop mentality is, I don't know what I've got coming next, and investing in things like automatic shut height, I'm going to have to set it anyways, and they don't see the value. But there is a huge value there to reduce downtime and reduce your changeovers. I think sometimes people just look away from that and don't see the long-term benefit of that, because they think, oh, this is a one-off job. Well, when does a one-off job become a repetitive job for you? Is it after you've run that same job 5 times, 100 times, 5,000 times? I don't know, but I think in all those instances, when you get to a certain level, once you've signed a contract, it has a value for you to invest in quick die change, automation, or robotics and things like that. And that's another area that I think people are underutilizing. What technology is that? What is it you feel is a great opportunity there? Well, robots. If you think about robots, they're number one, they're becoming much, 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 much more user-friendly. And since they are becoming more user-friendly, I always equate it to when computers started. When computers were first starting, you had to know the program. You had to know where the program was. You were just looking at a C prompt on a screen, and that was it. You had to know what you were typing and what you were looking for, where you were going to go, and how to get there. When graphical user interfaces came in, you could just click on you had a little symbol on the screen and you could click on it and it took you there. So that was all you had to do. It really changed things to make it more user friendly. The same is true now for robots, where we can physically move sort of on the cobot side, which are the smaller robots that are working in conjunction with people. They can physically move it from point A to point B, and they can describe how fast they want it to move, and the robot will perform that same thing over and over and over again. But it requires, you don't have to plug in a laptop to it a lot of times. They have readout screens that you can just tap a teach button and the robot will learn that new range of motion that it's going to be moving on. That is a huge game changer, in my opinion, for making robots accessible to people. And that's where we've struggled in the past, was if you wanted to put a robot in your plant, one of the things you were going to have to do is employ a programmer, because you needed somebody that could program that robot beyond just the operator of that robot. Now we can do that ourselves, the person who's operating it. And that seems to be the case for most controls too. Controls are becoming more intuitive. I think computers and phones and tablets all kind of change that mindset that, yeah, we have to program this, but why? Why do we have to do it? And the challenge of that, and I really think that if you think about technology and you talk about things like disruptors, that is a disruptor. That why? What is the why of we have to have a programmer? Why do I have to have a programmer? Why do I have to have somebody with a laptop tie into this? Why does somebody need to know the software for that robot? Why can't you make this like a tablet? Okay, and they responded. Most of these robot companies responded to that and said, yeah, why do we? I guess it's job security, but there was no real reason you couldn't program it in a user-friendly language and in a user-friendly, accessible mode. If you think about, there's a Lego robot competitions. Well, if you've ever seen these Lego robots, they're very drag and drop messaging. So if you want this to delay or move a certain amount, you just drag and drop and you type in how far you want it to move. And it's very user-friendly, very simple, so kids can use it. Well, that same methodology can be used in a lot of other things. It's also the reason why some of the programming systems like Python and that are more found now today, because it's easier for somebody who's a novice to get into it, and somebody who doesn't specifically want to be a programmer but has it as a need to do what they want. The robot person doesn't want to learn how to program it, but it's something that they needed to do in order to perform their job. Well, why did we do that? And I think, again, we ask that question, why, and it dictates the answer of we don't. We don't need to. So why are we making it so complicated? Spreadsheets. Why are vision systems, thinking of smart, why are vision systems so much more important today? Well, vision systems are fantastic because they can illustrate a very simplified version. Does the fact that we've run 15,000 parts so far this morning, does that mean something? It doesn't. Most people don't know what that number means. Is that good? Is it 15,000 good? Is 15,000 bad? Is it on pace? Is it off the pace? Do we have other problems that we're dealing with on it? And very simple indicators of red, yellow, green help people who are not directly impacted by the function of that machine can quickly see if it's running and that they need to make an adjustment or a reaction to it. Are we going to miss a delivery because we're in the red because we're behind on production on that machine? Are we going to shut a line down because of it? Those are the things that are important. It isn't, the number means nothing. So people that are numbers guys, and I apologize to most engineers out there because most engineers tend to be numbers guys and data driven. But to the other side of it, the administrative side of businesses, they don't have a value specifically on the information. The information is a means to an end. Are we on time? That's all I need to know. I don't need to know we've made 15,000 parts. I don't even know if we're making 15,000 good parts. So that's another part of that example of where IoT comes in. Are you verifying these parts? I was recently at a company, and they had vision systems integrated across the board, and it serves multiple purposes. Number one, it's an element of quality control, but you could do the same thing with using calipers or other types of GD&T. But the reality of a vision system is it also gives you a level of verification and confirmation. So your supply chain can see that we are doing the things that we want to do to achieve a certain level. ISO types of verification. It helps to track without somebody actually having to put numbers in, without somebody having to keep stacks and stacks of paper to verify that they've done things. The more IoT you can integrate, so the more sensors, the more vision systems, the more verifying tools you can use, the greater the chances are of not only proving that something's working, but verifying it. And when it becomes integral into your system, you run a less of a chance of getting away from it. For instance, when vision systems are integrated into most companies, it's not like a sensor on a machine. They get to the point where they instead, hey, if that vision system's down, guess what? People are ringing the bell from the top of that hill saying, hey, this vision system is down. We can't verify parts. Now, could you still verify parts? Absolutely. But now you've lost the confirmation side of that toolbox. I can see where companies are challenged by that. When we look at that from a whole company standpoint, there's a lot of value that they can see in technology. What other technologies do you see changing and coming up the pike here? Oh, I think without question, you're going to have a lot more AR and VR. I am actually kind of surprised at how slow some of this stuff has moved. There is a lot of it being done by various people around the industry for specific tasks. I know that Eric Kalm has done a lot of work with that. He's been on the show before, and Eric is very knowledgeable of using that. But in fact, it's something that I'm launching currently with Reality Safe, is how do you prevent people from being at risk when you're doing training? How do I make them smarter employees? Because a lot of times we don't do a very good job with training, and we don't do a very good job with making sure people understand technology. And it's something that we need to do better. Well, was talking to Ron at Pitcher Insurance, and we were discussing the aspect of safety, and it's all about reducing risk and reducing the exposure to risk. Why would I train somebody on the floor at 95, 97 decibels, screaming over the machines running to train them. If I can do it in a virtual environment and get 80% of that benefit, of that training, I'm doing it in an environment where it's controlled. I'm also not having to use a machine. So you want to talk about a green solution. Using VR is a green solution, because just running a machine takes a lot more energy and a lot more electricity to run a machine. Now, you could say you're doing it on the job and they're actually producing parts, but again, are they getting a good quality education of that? I think the problem is that you have bad practices begetting bad practices. So you have operators that think they know why they do things, and maybe they do, but they're not a trainer. So what happens is that, it goes back to the old story about the mother and daughter and the turkey. Okay, well, I always tie the legs back on the turkey or cut the legs off on the turkey, depending on the story, the way you've heard it. Well, why do you always do that? Well, I don't know. And they go and check with I did it because that's the size of the oven that I had. So that was the only reason that they did it that way. But continuing to progress that bad behavior does happen, and it happens in training a lot. They are not as focused on safety. They are not as focused on the whys of what we do, and consequently, it leads to some bad practices, and that's an unfortunate situation. But it can be changed using VR, where you're training on a piece of equipment, like Reality Safe, where you're actually training on a piece of equipment, and that is changing how you're experiencing it. And I can control the level of distractions. In this world, and I can control that there's no noise in the background when you're being trained. I can add noise so that when you're doing a process, you are experiencing distractions. I can then also take it to an AR level, where when you go out on the machine, you put on the glasses and you can see where the hazards are. So there's a lot of benefits to that in the long run. And I think in general, you can see where technology is improving in that. In additive manufacturing, we are making great strides in how we process new and advanced materials. There are new materials all the time. Amy Elliott from Oak Ridge Labs had been on the show before, and she had talked about what is possible with technology. What is it we can do? And I think you'll see a lot of people moving forward and pushing the boundaries of what can materials do, how can we produce parts that weren't even possible in any other way. That is amazing. Thank you so much for being here today, Dean. We're glad to have you as a guest on our one-on-one show. Tell people how they can reach you. You can reach me. The easiest way is you can find me on LinkedIn and look up Dean Phillips and Link Systems, or you can look it up under Longevity Industries, longevityindustries.com. That's Dean at longevityindustries.com. And if you have any questions, you can call me at 615-714-4442. Thank you so much for being here today. Everybody, go make it a great day.